Hi everyone, here's the quiz video for the Thursday's lecture of week 5, so week 5-3. First question, write a method that randomly shuffles an array of integers. So we are going to, here's my Sublime, I'm going to work in Sublime. Make sure everything's aligned. So we need an array of integers. We'll call it array. And we know it works for arrays of up to 5. The rest we're not sure of. So we'll start with 5 for now, and we'll work from there. We'll generate this array, we'll store random numbers into this array. So I'll do that using a for loop. We'll give it values of up to 100. There we go. Now, what I'll do is I'll print this array, and in order to do so, I'm going to import the array object. We'll just store that. There we go, and so we can see what kind of array we're dealing with. So if I print that right now, there we go. So that's our randomly generated array. Now we want to randomly shuffle this array. Okay? Not necessarily in order, we just want to randomly shuffle it. So what we're going to do is we're going to send this array to a shuffle method that we're going to create really soon. So this is a method I just created that is going to return an array of integers, and it's also going to accept an array of integers called shuffle. So this shuffle method is going to randomly shuffle our array. This method is also going to accept a position. So the position at which we're looking at in our array, and it's also going to accept a random position. Okay, this random position, okay, right here. So I'm right here now, creating a new variable, and this variable is going to store a variable. So it's going to restore an integer returned from a method called random, which we're going to create right now. This method does not need to accept anything. All we wanted to do is return a variable so that is equal to one of the positions within my array. So actually, scratch what I said. This method random needs to accept my array, and I'll show you why. So that here So here what's happening is that this randomly generated number using math.random, it can take on a number of between 0 and array.length minus 1, sorry. Array.length minus 1. And that number, so that will randomly be a number between 0 and 4 inclusively, and that will correspond to one of the positions in my array. So this now number that's generated, I'm going to send it to my shuffle array, to my shuffle method, okay? And this shuffle method is actually going to accept I, so the position at which it's currently at, X, the position that is the random position which I'm changing it for. To monitor the position which I'm currently at, I'm going to use a for loop. There we go. So now the I now is monitoring the position of my array, and this X is a randomly generated number, which is a value between 0 and 4, which corresponds to a random position within my array. And I'm sending those two positions with my array to my shuffle, and my shuffle method will now shuffle those positions. And that shuffle method is simply going to be a swap. So I'm going to store the variable at my position I of my array in an integer t. My position I of my array will now take on my position x of my array, because remember x is between 0 and 4 corresponding to a position. And my array at position x will now correspond to the t that I stored previously. And don't forget to return something. And this needs to return array. I also forgot to return something here. This needs to return x. So the randomly generated number here that corresponds to one of the positions. So now that it has been shuffled, we need to go ahead and print this array again, and let's check if it's actually been shuffled. So here we go, and it has. Not in order necessarily, but it's definitely been shuffled completely randomly. So write a method that randomly shuffles an array of integers. There you go. Now it says write a method that determines if an array is sorted. So we're going to create another method for this, a method of booleans. We're going to call it sorted, and it's going to need to take in the array of integers as an argument. And what it needs to do is it needs to check if this array of integers is sorted or not. So for int I is equal to 0, I less than array.length I plus plus. We're going to say if the array at position I is greater than the array at position I plus 1. If I'm going to do I plus 1, I need to do length minus 1. Okay? Boom. If that's the case, well then what I need to do is return false, meaning it's not sorted. And if that's not the case, we will return true, i.e. it is sorted. Now we need to kind of send, in our main method here, we need to send the array down to Boolean to check if it's sorted. So how we're going to do that, very simply, we're going to, right here, just send, we're going to print the statement. Okay, that's going to tell us if our array is sorted or not. So if it's false, it's not sorted. If it's true, it is sorted. Let's go do that. False, not sorted. Now, that's cool and all, but how about we make this code so this shuffle thing run until my array is sorted, until we get a true. So let's comment that line right there. In order to do that, we're going to be using a while loop. So while sorted, when I pass the argument array is false, I want all of this to occur. There we go. So while it is false, I want it to keep sending it to my shuffle right there. Now my shuffle is also being we'll work this out after. There, let's try this. It's building. Something's going on. It crashed. Wonder why. One second, I'm going to restart that. Okay, let's go figure out why it crashed. I know why it crashed. Because this random is only going to, first of all, it's only going to sort it once. So this needs to be inside our while loop. There we go, first of all. This should work now. There. And now it is in fact sorted. Okay, so this printed the array every time as it was being sorted, and as we can see, completely random every single time. Now we can refine this to make our code a little more efficient, because we said that I is always keeping track of the position. I was always going to know, we know what I is going to be. So I is going to be 1, 0 the first time, then 1, then 2, then 3, and then 4. Okay? But now this random, this random number, that's a position between 0 and 4, it can equal to this I at one point. We don't know what it is. So what we're going to do is we're just going to create a little if statement here that checks if my x, so my randomly generated right here, the random position, is not equal to my I, well then this should happen. Okay, right here. That should happen. Okay, so that just makes it a little more efficient, so that we're not just swapping, we're not just sending shuffle to positions that are exactly the same. So that just makes sure that the position that we're looking at, that's the random position we're looking at, is not equal to the actual position of our array we're currently looking at. And this will keep running, as I said, until it is true. So we don't really need this line anymore. So that's your method for checking if array is sorted or not. Now it says, is it possible to use the random shuffle method for some k times in order to shuffle an array? It should work for small arrays n less than 5, for which n this process is unbearable. So n being the length of our array, I'd like to put out a little notice: do not try this quite yet. you will do it manually after. But if n is the integer of our array, therefore we need n to go, we'll start with 6 because we know 5 works. So n is 6, and at the end here, here, when it's sorted and it all works, we're going to n plus plus, and we're going to start again. But we need to put all of that in a while loop that is true, because there we go. So technically this is an infinite loop, okay, and it will keep on augmenting n until this process no longer works. But the problem with that is that also what we can do here is that right before it augments n, you could print a line and check what n it's at right now. Okay, so this will keep on telling you. This will actually keep on augmenting your arrays. So we'll go from array of 5, to an array of 6, and it will do this whole process, to an array of 7. It'll do this whole process, and it'll keep going until it becomes unbearable. But because this is an infinite loop, it will crash, guarantee. Do not run this. What I advise you to do is manually change the n to a 6, test it out, change it to a 7, test it out. Do not run this. Okay? It works, but don't run it. Now the other thing also that we can do is check how much times this array needs to be sorted. So how much time it's being sent to shuffle before it's properly sorted. So how much time it's being shuffled before it's entirely sorted. And in order to do that, we're going to have an integer that's going to keep track. Okay, so it's starting at 0, and it's going to keep track of every time this array is being sent to shuffle. So right after it sends to shuffle, I augment my k by 1. Okay, so it started at 0 and I augmented by 1, and at the end of this whole system, we can print a nice little statement that says, you shuffled the array times. There. So you shuffle the array k times, and k will be printed in this case. So if we run this now with, say, a length of 6, let's see if 6 works. And 6 shuffled the array 5,355 times, which is a lot. So if we change now 6 to 7 instead of letting it go automatically, 7 does it 10,740 times. How about 8? 8 does it surprisingly less time this time around, but if we do it again, could be more. And 8 crashed, or not yet. 184,128 times. We can try 9. So because this is random, it's like 8 can generate, as we said, 6,000 times, or it can generate 184,000 times. And 9 seems to be crashing. Let's give it another minute. But 9 seems to be crashing, so I'd say our maximum is about 8. And my laptop's overheating, so I'm going to stop. But our maximum is about 8. There you go. And you could have easily done that, but as I showed you, using the while loop, an infinite while loop, and just keeping track of the number of n's and being your position, and being the length of your array, And this k, as I said, just keeps track of the number of times you shuffled it. But because it's random, you can, with an array of 8, once can be 184,000 times, as you saw, or an array of A can also be 6,000 times. It's entirely random. That's why it's not very reliable and it's not very efficient. But there's the video. Hope it helped, and I'll post the code online also.